All right, today we're going to talk about the first section of 5.5, different properties of quadrilaterals. We're going to focus primarily on parallelograms and a couple different special properties, special types of parallelograms. First one, the parallelogram. A couple different side properties that we are going to need to know for some algebraic problems and or proofs. First one is that the opposite sides of a parallelogram are parallel. We also know that the opposite sides are congruent to each other. There are a couple angle properties that we have as well. We have that the opposite angles are congruent and that the consecutive angles are supplementary. As far as the consecutive angles are supplementary, that is very much related to our parallel lines, our consecutive interior angles. And then we know that the opposite angles are congruent to each other. We also have one diagonal property, and the diagonals bisect each other. Now, any other shape that we talk about that is a special type of parallelogram will have all of the parallelogram properties and then some other properties. So, when we are talking about a rectangle, the rectangle has all the parallelogram properties and a couple special ones. And some of them that you guys have already known when dealing with rectangles. That all the angles are right angles. And then a special diagonal property is that the diagonals are congruent to each other. Another special parallelogram is the rhombus, and again, this one is all the parallelogram properties. And some special ones. And some of the special ones include the fact that all of these sides are congruent. Also includes that the diagonals bisect the angles. Another one is that the diagonals are perpendicular bisectors of each other. And then because of that, the diagonals divide the rhombus into four congruent right triangles, and that's what I was just showing with the perpendicular bisector part. As far as the square is concerned, the last one that we're going to talk about today, this parallelogram has all of the properties of the rectangle and all the properties of the rhombus. So we combine everything that we know about a rectangle and a rhombus, which already constitutes the parallelogram, and that will take care of our square. So we can use all of those things in a proof. When we're talking about a parallelogram, we can use any of those properties in a parallelogram. So first off, we will start with the fact that it is a parallelogram. And we want to prove that angle 1 is congruent to angle C. So we could, if we were working backwards, if we got these angles congruent, because they're in the same triangle, we could get those angles congruent by getting those opposite sides. So we need to bring in sides into our proof. And we can say that AD is congruent to BC because if it's a parallelogram, then we know the opposite sides are congruent. We are given another pair of sides already. And then we can say that BE is congruent to BC because of the transitive property. And then, as I just mentioned, we wanted to get there because now we can say that the angles that we want are congruent, because if the sides are congruent, then it's opposite angles. And that completes this proof. Our next one is a little more complicated. We have, it's going to be a little bit longer now. We need to know the properties of a rectangle. So when we look at this OGK that we want to prove is isosceles, we want to prove this big outside triangle is isosceles. In order to prove that, we need to first get that these sides are congruent to each other. And just like in that last proof, that if we can get those sides are congruent, we first need to get that the opposite angles are congruent. And G and K are angles, they're small angles in the triangles on the left and the right. So I know by looking at this, I want to try to get that those triangles are congruent to each other, and I'm going to start by writing down the rectangle. And if I have a rectangle, I know that all the angles are right angles, so I can state that 2 and 3 from the diagram are right angles. Now those are not in my triangles, but I know that if I have right angles, then I can say that segments are perpendicular to each other. After stating perpendicular, I can now go in the opposite direction and say, if perpendicular, that other angles are right angles. And so now I'm getting the angles that are inside the triangle. And after I state that 2 angles are right angles, I can say that those 2 angles are congruent to each other. I also know in a rectangle, because it shares the parallelogram properties, that the opposite sides of a rectangle are congruent. And then we are given another pair of sides. And then I can say the triangles are congruent by RHL. No 7 is bothering me. So now I've done, as I mentioned before, I wanted to get these triangles congruent, because now if I can get those triangles are congruent, as I look backwards at the very beginning, I can say that the angles are congruent to each other because I've proven the triangle's congruent. And then I can say from the big triangle that if the angles are congruent, then its opposite sides are congruent. Which tells me that the triangle is isosceles, because if it has 2 sides congruent, then it's isosceles. The next thing we're going to do is look at some algebraic stuff. So we need to know all of our properties. In this one, we are given the fact that this is a rhombus. In the first one, we are talking about ST is 13 and it wants to find SQ. We know that diagonals are perpendicular bisectors of each other. So I know that this segment has to be 13, giving me SQ a measure of 26. In the second one, I know that PRS is 17 degrees and it wants to find QRS. Well, again, I know that the diagonals bisect opposite angles, so I know that this angle is also 17 degrees, giving me a measure of 34 degrees. In number 3, it doesn't give me anything, but it's asking me to find an angle that is formed by the perpendiculars intersecting, and I know that the diagonals are perpendicular bisectors of each other, therefore the angle must be 90 degrees. The last one gives me a measure of a side, 4x minus 3, and another side of 18 plus x. And in a rhombus, I know that all of the sides are congruent to each other, so I can set 4x minus 3 equal to 18 plus x and solve for the measure of x. Go ahead and take a minute and finish 6 through 10 here, also dealing with a rhombus. So I get my answers up here as shown, and this is by knowing that the diagonals are perpendicular bisectors. I also know that the diagonals bisect the opposite angles, and that all sides are congruent. The next one, we're going to look at properties of a square. Some of them are very similar to, or they are, some of them are from the rhombus. So in this first one here, we know that AEB right here is 3x. Well, I know that diagonals are perpendicular to each other, so I can set 3x equal to 90 and solve for x. In the second one here, I see that BAC is 9x. Well, I know that all the angles are right angles from it being coming from the rectangle, but then a property from the rhombus that we need to know for a square is that the diagonals bisect the angles. Therefore, I know that 9x has to be equal to 45 degrees because I'm bisecting a right angle. So I can get x is 5. In the third one, I'm getting two different sides, and I know that all the sides are congruent in a square, so I can set them equal to each other. And because I get x equals 9, I need to answer the question here. It says find BC. So when I plug 9 back in, I get a measure of 22 for this side, which has to be the measure for every side of a square. For number 4, DAC being y is right here. Again, as mentioned for number 2, because the diagonals are bisecting the angles, and I know that all the angles are right, I know that y has to equal 45 degrees. And for BAC being 3x, same thing, I can set 3x equal to 45 and solve for x. Would like you to finish the last few here. They are not they're not terribly hard. They're pretty quick based off of parallelogram and rectangles. So go ahead and finish the last couple slides, and we will check those in class next. So that concludes section 5.5.